Dear participants, let us move forward towards the last topic of Unit 3. Here we will be studying the concept of Master Control Relay (MCR) and its implementation in PLC ladder logic. Now you see that whenever we are in a situation that there are very large number of outputs that are being operated with a PLC. All right. It may so happen that you can or cannot, I'm just taking an example, classify or make a collection of the outputs in separate zones. For example, let us think of a production line where four conveyors along with different sensors and actuators that are associated with each conveyor are being controlled by a single PLC. If such is the situation, then this concept of master control relay is very interesting. This particular concept gives you the power to decide which zone can be turned on or it can be turned off if the situation demands like that. Suppose there is no such provision as MCR in a certain connection. Now four of the conveyors are working, everything is going fine. Suppose at this point one production line has developed some error and it has to be stopped. So if you do not have the facility of an MCR, then what will happen? The entire four lines will be needed to be stopped. So your entire operation will be hampered. Your production will be seriously under threat. Another point is that if suppose some untowardly accident has happened at a particular point, but there is no goodness of shutting down the entire plant or an entire line for that, then you can isolate that zone electrically, carry out the necessary repairing, and again you can come back to join with the already continuing work. Now, if this has to be done, then we can think of one immediate solution. We can use one internal, maybe one internal relay for each and every line, and the contacts of that relay can be used in each rung of that line. You got my point? Suppose that there are four lines as I had told, and for controlling each line there is a program, ladder program of maybe 16 rungs. So what you can do, at the first rung of each, I should say, this ladder that are destined to operate each production line, you can put one internal relay, and then you can use the contact of that relay in each line of that rung. This is possible, but definitely you can think that the program will become a bit cumbersome. the best alternative that can be used is a master control relay. So you see, this master control relay is actually a hardware concept. In PLC, it is master control reset function. So first we will go into the concept of master control relay, MCR. Now you see that here there is a master start switch, master stop switch, and here is the MCR coil. And open contacts, normally open contacts of the coil are connected here. So this, whenever we energize this MCR, this entire circuit can be either brought to the energy or it can be taken to a shutdown. So this is the basic operation of a hardwired master control relay circuit. You see one thing, that unless this relay is energized, it is for sure that no power flow can take place from this master line to this branch. You can see we call it the load side, because from the MCR point of view, this is the supply side, that is the upper side, this rung, first rung, it is the supply side, and all the rungs they are beneath this MCR contact, they are the load sides. Okay, fine. Now let us try to implement the concept of MCR in the ladder diagram. You see here, in this case, this is the master control relay. Okay, so this signifies the coil. So whenever input 1 is closed, this control relay is energized. And when this happens, then you can see this NO contact, this will be closed and all subsequent rungs will get power. However, you have to remember one thing, that there should be another point, another coil. In between this MC1, you can see this coil and this coil, in between this only, the rungs will get the supply. Now once this is not activated, that this relay is not activated, then even if you activate input 1 or input 3 manually or through some process, this output 1 and 2, they will never get activated. Alright, so this is important. Now there is nothing to be very surprised with that, because power is not coming to the line. Then what is the goodness of putting these switches in activation? Okay. Now you see that PLC manufacturers actually they offer a particular form of master control relay in their instruction set. Remember, the instruction functions as a hardwired master control relay. When this is true, that is the MCR instruction is true, the circuit functions normally. And when this is false, remember, all non-retentive outputs are switched off. Non-retentive outputs. This means that any output that does not retains its state when the power is off. So what will happen if the power is off? That means the master control relay, this instruction is false. Then power will no more be delivered to that branch in which that MCR is being operated. If there are outputs that are of non-retentive type, they will simply go switched off. And if they are retentive type, they will be retaining their the then values, the then conditions rather. But remember, these are never the hardware objects. These are simply a software function or a software facility. Therefore, remember that master control relays, they are very much required for safety point of view, because if some problem has been arrived, immediately one branch or one zone can be isolated. Emergency input output, that is IO power shutdown, can be achieved with hardwired master control relay. So that should not be substituted by this software function. Okay, so this alarm you must keep in your mind. Now you see that master control reset, it is the instruction. It is the instruction. Earlier we have studied master control relay, MCR. Now this is master control reset instruction. It is an output coil instruction, okay, that functions like the master control relay. You see, MCR coil instruction, whenever you are going to use it, they are always used in pair. They are always used in pair. You may like to control the entire circuit by taking the circuit within these pairs, or you can make selected rungs to be controlled by putting them within these pairs. This you have to remember. Let us go for this illustration. You can see these are the inputs. This is main on off switch that is controlling the MCR. Then there is a stop start switch for this M. This M, maybe it is a motor. Then there is a level switch that activates lamp 1. There is a limit switch that activates solenoid 1, and there is another limit switch that deactivates solenoid 1. You can see this is latch output and this is unlatched output. So this is latch coil function and this is unlatched coil function. So if this switch LS1 is activated, I should say it is true, then the solenoid will be energized, and when it is false, the solenoid will not be energized. Now you see that here importantly, this solenoid is having latched input and output. However, the motor is not having a latched coil, and this lamp, this pilot lamp, it is not also having a latched coil. What does that signify? See, when this is on, the MCR is on, and therefore this for second, third, fourth and fifth, all the rungs will remain activated because it is within the ambit of this MCR coils, this MCR coil 1 and MCR coil 2. So since they are within the ambit of these coils, within the circumference boundary of these coils, or technically we can say that it is the fencing, within the fencing of these coils, all of them will be activated normally. However, remember that if it is deactivated, then the motor will go off. Whatever is its condition when it was activated, irrespective of that, it will go off. The pilot lamp will go off. However, if the solenoid is on, because when the MCR was activated, the solenoid was on. If it was on condition, it will retain that because this is a latched output. So all retentive outputs remain in their last state, and all non-retentive outputs, these are simply de-energized. Now you see that it is written over here. The benefit, I am going for the point 2. The benefit of MCR instruction is that it simply establishes a zone in the user program. By proper application of this MCR instruction, you can see all non-retentive outputs can be turned off simultaneously. You can see here that if you want this and this output to be off, you have to put off a switch here, the label switch has to be activated here, that you have to do. But simply using this MCR instruction, whatever non-retentive outputs are there, they can be at a time de-energized. Now you see that it is a common practice that retentive instructions are normally not placed within an MCR zone. Okay, because the last active state will be retained. Suppose there is a cutting tool. There is a cutting tool, maybe a paper shredder or something like that, where a heavily loaded cutter comes down and it cuts a bunch of paper. I'm just taking an example. Now some that accident has happened and immediately that cutting tool has to be stopped. Now suppose if it is connected to a non-retentive output, what will happen? Although you have de-energized the MCR, that function will be continued. So therefore, you should never keep, at least you should try your best not to keep retentive outputs within the MCR, because MCR will help you in isolating a part of circuit in case of any problem so that it can be stopped immediately. But your retentive one, if it contains a conveyor, it will keep on operating. So that will not give you the result that you require. Okay. So this you have to keep in your mind. Next, you can see one important concept is there. If you have connected an off delay timer and you want that this off delay timer should be activated because of some physical situation, maybe there is a limit switch that is operating, or that is the control element for this off delay timer. When the limit switch is pressed by an object, the timer gets its signal that yes, whenever it is depressed, whenever it is released, it should be starting its operation. Now under such a condition, suppose that MCR is deactivated. Now when the MCR is deactivated, whether that limit switch is pressed or it is released, that will not make a difference. There will be no signal to the timer. So immediately the timer will start timing. So this will be a false timing. Therefore, while using an off delay timer, be very sure that whether you are using within the MCR zone or not. If you are using it in MCR zone, you should be very careful, rather not to use that. Now you see here that an illustration circuit is given in front of you. What is there in the circuit? You can find that the first rung to be the start fencing for the MCR, and the last rung is the end fencing. In between there are other objects. Let us go for a check. You can see there is an input switch. This I, that is input A, it activates or deactivates the MCR. Then there is a normally closed push to off switch to deactivate this output A. Normally the output will be on, okay, if the MCR is activated. Then there is a timer. The timer is controlled through this push to on switch input C. Then there is output B. Now this output, you can see it is used as latch unlatch output, and for latching operation to be executed, this proximity sensor D is used as input D, and in order to get the unlatch operation to be activated, that is to unlatch this output, you have to energize this input E, which is again a proximity switch. Now you see, if input A is true, that means if it is energized, then the entire rung will be operating. The output A will be on, the output B will be on, and the timing operation will be on as well. Now suppose we have opened the input A, that means this switch is now open. Although switch B, that is input B, is in contact right now because it is a push to off switch. Normally it is closed. You can find the output is off. The output is off because the MCR is now deactivated. There will be no operation by the timer as well. And you can find that since the output B was in on state, when the MCR was activated, it will be retained with that state only, because you can see it is an latched output. The latched output signifies that once it is on, unless it is unlatched, it will not be off. That means once it is activated, in order to deactivate this coil or output, you have to unlatch it. So since before the MCR was deactivated, it was in on condition, it is retaining its on condition because of the retentive nature of the output. So this is operation of this MCR, a master control reset instruction. But again, I would like to warn you that this master control reset instruction can never be a substitute for MCR, master control relay, that is a hardware component. Thank you for now. For any of your confusion, please let me know.